All right, now we're going to go the opposite direction. Now we're going to convert polar equations back to rectangular equations. So here are some strategies we can use to do that. We can cross multiply. We can multiply both sides by r. We can square both sides. Keep all of this in mind. So remember, x equals r times the cosine of theta, y equals r times the sine of theta, x squared plus y squared equals r squared, equation of our circle, and tangent of theta equals y over x. All right, so number 5, we've got r equals negative 2 times the cosecant of theta. Well, reminder that cosecant of theta is equal to 1 over the sine of theta. So we can multiply both sides by the sine of theta to get r times the sine of theta equals negative 2. And we know that r times the sine of theta equals y. So we're able to replace that entire left-hand side with y and see that our equation is y equals negative 2, which is a horizontal line. So for each of these examples, we're going to convert from polar to rectangular. We're going to name the type of graph. So this is a horizontal line, it's linear. We're going to check by graphing the polar equation on your graphing calculator. So let me graph this original equation and verify that it is in fact a horizontal line. Let's go back here. Okay, so the original equation was negative 2 divided by the sine of theta. And so there's our horizontal line down at y equals negative 2. All right, so number 6, r equals negative 4 times the sine of theta. So we don't want to divide by sine of theta now because that's not going to help us to get this. So now we've got to kind of aim for this one. So let's multiply both sides by r, because if we multiply both sides by r, now this side then I could replace with this. So let's try strategy number 2. Let's multiply both sides by r. So if I multiply both sides by r, we get r squared equals negative 4 times r times the sine of theta. And we know that r times the sine of theta equals y. So we've got negative 4y. And on the left side, we know x squared plus y squared equals r squared. So we can replace the r squared with x squared plus y squared. And so we can see we're ending up with a circle, but let's get this into the graphing form or the standard form for the circle. So let's move that negative 4y over to the left-hand side. And now we'll complete the square. If I add 4 to both sides, now I'm able to write that as y plus 2 quantity squared equals 4. And so it's definitely a circle. The center will be at 0, negative 2, and the radius of 2. So let's go ahead and graph it, the original polar form, and see if we're right. So negative 4 times the sine of theta. Yep, here's our circle, centered down at 0, negative 2, with the radius of 2. All right, so r equals 4 times the cosine of theta minus 4 times the sine of theta. So again, these are kind of close to what y equals and x equals, but they're missing the r. So let's go ahead and multiply both sides by r again, so that we end up with r squared equals 4 times r times the cosine of theta minus 4 times r times the sine of theta. So we can replace r squared with x squared plus y squared. And here this becomes 4x and this becomes 4y. And so again, we're getting a circle, but let's get everything on one side so we can complete the square. So we'll have that, plus we'll need to add something, and then we'll have y squared plus 4y. And we'll need to add something to complete the square, now equals 0. So remember, to complete the square, we're always taking the coefficient of the linear term, dividing it by 2. So negative 4 divided by 2 is negative 2, squaring it. So that's positive 4, and that's what we're going to add to both sides. Make sure you do both sides of the equation. So you add it here, but you got to add it here as well. All right, this one's the same. Half of 4 is 2, 2 squared is 4, so we've got to add 4 here as well. So that now we can write this as x minus 2 quantity squared plus y plus 2 quantity squared equals 8. So again, it's a circle. The center is 2, negative 2, and the radius is the square root of 8. which is 2 times the square root of 2. All right, so let's graph the original and see if we're right. So 4 times the cosine of theta, make sure to close that parenthesis, minus 4 times the sine of theta. There's our circle, centered over at 2, negative 2, and then the radius 2 times the square root of 2. All right, so number 9, we've got r times the cosine of theta. Well, that's x. Remember that r times the cosine of theta equals x. So we just replace that entire left side with x. We get x equals 6, which is a vertical line through the x value of 6. And so if we graph this, go back to y equals, clear that out. So it would be 6 divided by the cosine of theta if we solve it for r, which is how we have to enter it into our graphing calculator. And so there's our vertical line at x equals 6. All right, a couple more here. So again, this one, we've got things that are really close to being equivalent to x and y. They just need an r. So let's multiply by r. Distribute it through the entire equation. So we get r squared equals 2r times the cosine of theta plus 3r times the sine of theta. So we can replace the r squared with x squared plus y squared. And this is 2x plus 3y. So again, we know it's going to be a circle, so let's move it over so we can complete the square. Get it into that graphing form. Ooh, no, I would have had to subtract it over, so that should be a minus 3y there. All right, so half of 2 is 1. 1 squared is 1, so I'm going to add 1 to both sides. Half of 3 would be negative 3 halves. Squared would be 9/4. So I'm going to add that to both sides. So then I can write it as x minus 1 quantity squared plus y minus 3 halves quantity squared. So 1 would be 4/4 plus the 9/4 gives me 13/4. And so again, circle, since it's x squared and y squared, the center would be positive 1, positive 3 halves, and the radius would be the square root of 13/2. So let's check this quickly. So 2 cosine of theta plus 3 times the sine of theta. There's my circle centered at 1 and 1.5. Radius square root of 13/2. All right, so this last one, we need a different strategy that we haven't used yet. See how we've got this fraction on the right side? We've got a cross multiply here. All right, so in this next one, we're going to use a different strategy. We're going to cross multiply. We haven't done that yet. So if we cross multiply, we'd have r times the 1 minus cosine of theta has to equal 1 times 3. And so if we distribute the r, we get r minus r times the cosine of theta equals 3. And we know that r times the cosine of theta is just x. So we can replace that with x. So we have r minus x equals 3. And then let's move that x to the other side. So positive x, positive 3. And let's square both sides now. So that we will get r squared equals this quantity squared. And we can replace r squared with x squared plus y squared. And we should go ahead and multiply this side out. So we'll have x squared plus 6x plus 9. Remember, do good algebra. You have to take x plus 3 times x plus 3. So distribute the x, distribute the x, distribute the 3, distribute the 3. So you'd have x squared plus 3x, which gives us the 6x in the middle, plus 9. And so now, if we solve for y squared, we'd subtract this x squared from both sides. And we'd see that y squared equals 6x plus 9. So this is a horizontal parabola, since it's y squared instead of x squared. So that is how we convert from polar equations to rectangular equations. Again, we've got different strategies we can use. This last one we had to cross multiply and we had to square both sides. Sometimes we need to multiply both sides by r. Our goal is just to get one of these things so that we can replace the r and the theta and end up with x and y in a rectangular equation rather than a polar one.